So we figured out when a was -1 that it flipped it upside down. When a was 2, it made it skinnier by a factor of 2. In other words, your jumps were doubled. But what happens when a is a fractional value of 1/3 while your h and k are still 0, 0? If you need me to rewrite it, just to show you, this is y equals 1/3 x minus 0 squared plus 0. So h and k are both 0. My line of symmetry, of course, is x equals 0 still. But what does the 1/3 do? Now I'm going to strategically pick some points here because I know whatever I'm squaring I'm going to have to take a third of, and rather than take non-integer values, I'll take multiples of 3. So let's make this -27, -9, -3, 0. Let's do 1 as well. I don't know what 1's going to do. Well, I'll take 0. And 3, 9, 27. Let's just try those, even though I don't have 27 on the grid. Let's see what happens. So -27 squared. Let's see what that turns out to be. Pull up my trusty calculator if I can find it. 27 times 27, 729. So this is 729, but then times a third, which is the same as divided by 3. This turns out to be 243, which is, again, a point I can't fit. -9 squared is 81, divided by 3 is 27. -3 squared is 9, divided by 3 is 3. 0, 0. 3, 27, and 243. So one thing I could do is change the scale to reflect what I have going on here. So maybe every 1, instead of having it be 1, 2, 3, I'm going to have this jump by 3. So 3, 6, 9, 12, 15, 18, 21, 23, 25, 27. At least I can fit some points now. And to reflect what's going on the y-axis, I'll make the same scale, even though I'm not going to be able to fit it all. At least I'll fit a few more points. 3, 6, 9, 12, 15, 18, 21, 24. You don't have to put every point. 3. Okay, so when x is -27, which is the equivalent of -9 here, 243. I can't fit that. So -3, -6, -9. So the 3 over, I should be going up to 27. Right there. At -3, which is just 1 tick over, I should be at 3, which is 1 tick up. 0, I should be at 0. It's up there. And then my symmetry. So this looks a lot like y equals x squared. But I changed my axes to make it look like that. And in fact, if I didn't change my axes, and just graphed it as if everything was 1, I'll do that in red, I could fit 0, 0. Now I'd have to go to -3 and go up 3. 1, 2, 3, 1, 2, 3. So it'd be there, and it would also be here. This is if I didn't change my axes. This is what it would look like. And then I'd go over to 9, and that'd take me up to 27. Way up here. Yeah, way up here. You can see that it would be fatter because the jumps aren't as drastic for every x I go over. So it appears like the a less than 1 makes it skinnier. And if you look at these jumps, this is going up 1 really, right? It's going up 3 for every 3. This is going up 14 for 6. 14 sixths. What is going on? What is going on here? This is now going up it's hard to see with these numerical choices, but what's really happening here is that my A value used to be +1, +3, +5, and what's actually happening is this is getting multiplied by 1/3 for every 1 jump. Now if you want to see that, I'm happy to demonstrate. Probably a good idea for me to show you. So if I were to just choose my regular values that I've been choosing, 1, 2, 3, 4. Now this is going to be hard to plot, but it should show you the jump pattern at least. 0, 0. -1, 1/3. -2, 4/3. -3, 9/3. -4, 16/3. And the same mirrored here. 1/3, 4/3, 9/3, 16/3. And that should look a little familiar. 1, 4, 9, 16. They're just thirds, right? So instead of going up 1, I'm going up 1/3. Instead of then going up 3, I'm going up 3/3. Then up 5/3. And same below. So really I've just taken my +1, +3, +5, +7 and multiplied it by 1/3, and that's my new jump pattern. Okay, so A less than 1 makes it actually it doesn't make it skinnier, it makes it fatter. Fatter by factor of A, or A times jump pattern equals new jumps. HK still remains my vertex.